Hello and welcome. Cisco Flex VPN on iOS with local authentication and local authorization. Actually, due to the work from home situation, I've received many requests on how to build a home lab for Flex VPN on Cisco iOS router as VPN gateway and any Connect software as the remote client. I recorded this video to illustrate very basic home lab setup with minimum resources, so that anybody who wants to start with a simple practice on the technology or who wants to deploy this solution can use it. So this is not a training session and we are not going to discuss the details of the configuration and protocols. The idea here is to set up everything on the VPN server from the scratch and keep it as simple as possible, so that people can get it up and running very quickly using GNS3 or even actual either virtual or physical devices. Let's look at our topology first. As I mentioned before, the idea is to keep everything simple with minimum resource requirements. So as you see in diagram, we have a Cisco iOS V router as the VPN gateway and CA server connected to the PC via this cloud. The connection is to the MS loopback adapter on the client side, so that I can use the PC as the remote client using Cisco AnyConnect client software pre-installed on it. Now let's get started. First things first, we are going to start with basic management stuff of configuration. Let's give it a host name of VPN. Then create a loopback interface that we normally do as the management interface. We also want to use the IP address of this loopback interface using unnumbered feature for remote access tunnels. Let's say loopback 0 with the IP address of 10.1.1.1/32, and then give IP address for interface gig 0/0 with the IP address of 10.10.10.1/34. Activate the interface. Actually, this would be an IP address from your public IP address range, so that clients can reach over the internet to the VPN gateway to this IP address. You may also use private IP address on the VPN gateway if it is behind NAT. Here in our lab, we are using private IP addresses just to show you how to configure the technology. Before moving forward and do the rest of configuration, let's check the connectivity between the remote client and this VPN gateway. Let's open the command prompt on the PC side. Ping 10.10.10.1. There we go. We have basic IP connectivity between remote client and the VPN gateway. Now we can go ahead and jump into the VPN configuration. Before diving into the actual configuration, let's have a quick look at the configuration pieces of Flex VPN. As you see on the left hand side, there are two blocks for the IK v2 init phase, and they are IK v2 proposal that's used inside IK v2 policy. IK v2 proposal is used to specify encryption, integrity, DH group type of things, used to create a secure negotiation channel. But in our case, we are going to use the smart defaults on Cisco iOS XE, so we don't need to configure either IK v2 proposal or IK v2 policy, as default settings are good enough for us. The next item that needs to be configured is IK v2 profile, which is going to contain several items that you see in the picture. Under the IK v2 profile, we have to match the identity of the remote site. Then we are going to specify the local and remote authentication methods, specify the trust point name that we use to get digital certificate from, and then we have to enter authentication and authorization parameters. And finally, we are going to bind this profile to a virtual template interface. After configuring iProfile, we will create an IPsec profile. As I said before, we will use this default
where possible, so we don't need to configure IPsec transform set 2, as we will use the default transform set. Under IPsec profile, we are going to bind the v2 profile that we created, so we will bring everything together under IPsec profile, and finally we will bind this IPsec profile to tunnel interfaces by applying it to the virtual template interface. Now let's dive into the configurations step by step and use the parameters shown on the right hand side of the picture. Let's give it a domain name, homelab.net, and then generate the key pair, crypto key generate RSA with a key length of 1024. Key is generated. Now let's configure the CA server that's going to issue digital certificate for the VPN gateway. Let's say IP HTTP server, crypto PKI server with the label of CA. Issuer name .homelab.net IT and C equals TR. Let's say grant auto.
Now we can activate the CA server. Let's say no shutdown. Then we should create a trust point so that we can send certificate signing request to that trust point to enroll a system certificate for the VPN gateway. Crypto PKI trust point with the name of iOSCA. Enrollment URL would be http 10.10.10.1. We don't want to check for revocations, so revocation check none. Now we should install the C8 certificate first before enrolling for certificate. Crypto PKI authenticate iOSCA. Yes, we accept this certificate. The certificate of the CA server installed. Let's verify that by show crypto PKI cert. As you see, the certificate of the CA server is installed. Now let's enroll for certificate, system certificate. Crypto PKI enroll iOSCA. Crypto PKI. Oh, I mistyped it. Crypto PKI enroll iOSCA. Oh, passwords did not match. We don't want serial number in the subject name. We don't want IP address in the subject name, so say no, and finally request for the certificate, yes. The request sent and the request, the certificate received from certificate authority. Let's verify this. Show crypto PKI cert. As you see, the certificate for vpn.homelab.net with the host name of the same is issued by the certificate server. So the certificate part of the configuration is finished. Now let's go ahead and configure AAA. Let's say AAA new model to activate AAA. AAA authentication login with the name of auth-c. We will use local database for authentication. AAA authorization for network access with the name of auth-z, local authorization. To populate local database for authentication, let's create a username. Username test with a password of, let's say, Cisco. Before getting into the IKv2 profile configuration, we need to define IP addresses that the VPN gateway is going to assign to the remote clients. So let's say IP local pool IKv2_pool. Start from 172.16.5.10 to 172.16.5.20. By default, all traffic from the client PC will be protected and sent through the tunnel. So let's configure a split tunnel ACL. So allow only selected traffic to go inside the tunnel. IP access list standard split ACL permit 10.0.0.0 with a wildcard mask of /8, let's say. Now we will bring these two together under IKv2 authorization policy and apply them to an IKv2 profile. Crypto IKv2 authorization policy with the name of IKv2_auth_z_pol for policy. Pool IKv2 pool and route set access list name of the ACL split underline ACL. The authorization policy for IKv2 created. Now let's create the IKv2 profile and bring all the pieces of IKv2 together under this profile. Crypto IKv2 profile with the name of IKv2 prof. We have to match the identity of the remote site, match identity remote with a key ID of $any connect client. AnyConnect uses this value as its default identity, although you can change it, but we will use this default for the lab. Authentication local RSA seek, so the client will authenticate the VPN gateway using its digital certificate, and then let's create an AnyConnect IP method of authentication for the remote end. Authentication remote AnyConnect IP aggregate. Let's specify the trust point that we got certificate from, and then let's apply the AAA authentication list we created before to this profile. AAA authentication, what was the name of the authentication that we created? AnyConnect IP auth C. Now let's bind AAA authorization and IKv2 authorization policy to the profile. AAA authorization group IP auth Z, and then the IKv2 auth Z policy, where we define the pool and access list. And finally, bind virtual template interface number to this profile. Virtual template that we are going to use is virtual template 1. Okay, the configuration of IKv2 finished. Now we will go ahead and create the IPsec profile using the default IPsec transform set and bind the IKv2 profile to that. Crypto IPsec profile with the name of IPsec underline prof, and set IKv2 profile to IKv2 underline prof. Let's disable HTTP services on this gateway and say let's no crypto IKE v2 HTTP URL certs and no IP HTTP server, no IP HTTP secure server. The certificate server is stopped. And finally, we will create the virtual template interface and apply the IPsec profile to that. Interface virtual template 1 with a type of tunnel. IP unnumbered loopback 0 that we created before, IP MTU 1400. Tunnel source would be gig 00 on this gateway, and tunnel mode of course IPsec IPv4. And let's apply the IPsec profile to this virtual template. Tunnel protection IPsec profile of IPsec prof. This virtual template is not an interface actually. It contains only the template of configuration that we are going to apply to the dynamic tunnels. When a remote client establishes a connection to the VPN server, a virtual access interface or tunnel will be created, and the configuration of that virtual access interface is inherited from this virtual template interface. That's it. The configuration of router is finished. Now we need to do some tweaks on the client side. On iOS XE versions older than 16.9.1, the AnyConnect client tries to download the XML profile after login, and if the profile is not available, the connection fails. So we are going to disable the AnyConnect profile download feature on the client itself. To do so, we will modify the AnyConnect local policy XML file. The file is located in this path. Let me show you. Program data, Cisco. This file AnyConnect local policy XML. We should edit this file and change the parameter, which is by default false here, bypass downloader, to true. This should be true. You can also edit the file using any text editor. I've done this before. Then by default, AnyConnect client tries to connect to the gateway using SSL and will not attempt to establish tunnel using IKE v2 IPsec. To change this, we have to create a profile with the name of acvpn.xml, which is located under this path, as you can see here. IPpred sample acvpn XML file and will provide you the link to download it. If you have that file, you need to edit the file, and under the host entry part of this XML file, here on the host name, I used FlexVPN iOS as the label for this VPN connection, and I gave the IP address of my VPN server here. You can do the same and save the file. Now the VPN connection settings on the client side is finished. Let's try to connect to this VPN server. As you can see, the label of FlexVPN iOS is listed here. Let's say connect. Security warning because the certificate signed by iOS itself. So let's
say connect anyway and use the username of test that we created with the password of Cisco. As you can see, the interface virtual access changed state to up, dynamically created on the VPN server. Show IP interface brief. We can see that virtual access interface is now up with the IP address of the loopback interface that we created. Virtual template is down because it's not an actual interface. Show crypto IKE v2sa. We can see the security association of IKE part of the VPN connection. Show crypto IPsec SA. As you can see, client has got an IP address of 172.16.5.10 from the pool that we created. That's it. I hope you enjoyed this and you can do the same lab at home. See you next time.